All right, yes, thank you. And next up, we have Beth Hill from Verity Software House speaking on GemStone 2.0, a single point solution to analysis of high dimensional, flow, spectral, and mass cytometry data, getting started with GemStone. All right, go ahead, Beth.
There are so many different choices to high dimensional data right now that it can be very confusing for users to figure out what the best choice is. So we would like to offer you a solution that can not only analyze your high dimensional data, but give you a whole different way of looking at it. GemStone was originally designed for the automation of high dimensional data from the very beginning in 2009. And we have recently revised the user interface and added some features that can really offer you a whole comprehensive package to get the most out of your data. So we've just released GemStone 2 a few months ago, and it is a integrated package that allows you to do an automated analysis where you build models that can take care of any number of measurements, any number of data files. It includes data analytics where you're enumerating different cell populations, any kind of tissue, any kind of samples, any measurements of your own panels. The cell populations are clearly distinguishable. We combine information from supervised and unsupervised analyses. And one of the really important features in GemStone is what we call our Cen-se map. What you're looking at here are this is 33 color data that Cytec has provided to us, so thank you, Cytec. And it's a PBMC sample, and you can see this, what we call our Cen-se map on the left is a normal PBM sample. And on the right, there's definitely something different about this. And this is, so how do we know what is going on? And what happens when you find something like this that's unexpected? What happens if your data does not actually follow the rules that are imposed on you by other algorithms? So I'm going to tell you a little bit about how we get to this point. And I'm going to do, hopefully if the fates are with me, I'm going to do a demo too. The basis of GemStone is called probability state modeling, and this is an algorithm that's been published. It's been around for quite a while now. There's a paper, I'm not going to read it to you, you can look it up, it's on our website as well. And GemStone is not a black box. You can see your entire analysis, you can confirm whether it's working and make changes to it if you wish. There is no scripting or coding involved, so we've tried to make it as seamless for you as possible. I'm going to give you a little bit of background, just to very briefly, about probability state modeling so you just understand what I'm talking about. So a probability state model is comprised of one or more cell types based on your panel, and you can think of cell types as CD3 positive T cells, CD8, CD4 T cells, B cells, monocytes, dendritic cells, etc. And within each cell type, there are a set of expression profiles that control the fitting of these specific measurements in your panel. The expression profiles determine the probability of an event being included in a particular cell type. And then the expression profiles are actually governed by these control definition points. We abbreviate that to CDPs. The control definition points are really the heart of the program and that determine the what will be included in a particular cell type. If we're looking at an expression profile, I'm going to give you a little bit of a way to look at this. Up here on the top right, there's a DNA, very simple 1P histogram with one peak. You can see very clearly that there's a little bit of debris here, but we have a peak. If I turn that on its side, and I now have my intensity on the y-axis, my frequency is now on the x-axis, I'm going to bring it over here to my expression profile. I'm going to even out the events. And now we have an expression profile. The y-axis, again, is the intensity. The x-axis is what we call cumulative percent. And what that really means is that it's showing you 0 to 100% of your events in that particular cell type. There is a peak finder system in GemStone that identifies peaks based on the density of events. So in this case, we're just finding one peak. We can see it very clearly. And the other important part of this is that these events are evenly distributed. When you read a file into an expression profile, just a raw data file, this is also in acquisition order. So it's a really good quality control measure when you're wondering if your acquisition was done properly. There's also something in GemStone that we call progressions. These are, you can think of this as a phenotyping of subsets in a particular cell type. So as we know, and Alina just set this up perfectly for me, thank you, but gate-based analysis is really subjective. It does not scale up well, and it does not account for transitional events. So we can take, again, a very simple example. This is CD27. And we know that CD27 in B cells upregulates as B cells mature or progress into memory cells. So if I take this, I turn it on its side again, intensity is on the y-axis, frequency is on the x-axis, and I can have over here on the left an expression profile. We call this, in this particular case, a step up. And all that means is that CD27 has upregulated at some point in the progression or maturation of these particular B cells. The important part here is that the program then reorganizes the events so that the CD27 negative events are to the left, this purple peak, CD27 positive events are to the right in this sort of magenta peak. And we can see that we have a step up, it's taking care of our transitional events, and everything is accounted for. The heart, again, of the program are these control definition points, and each set of the control definition points is a mathematical function that defines a probability distribution. So the CDP is positioned on the peak of interest to what we call select for that particular peak. And these control definition points are flexible to account for the variations in intensity, but they're constrained so that we really only select that peak of interest. The program then calculates a probability for each event based on the expression profiles and looking at all of the expression profiles and cell types, and then determines a total probability for each event, which then determines which cell type the event is assigned to. You can see a close-up here. There's a line above and a below in the CDP, and that determines the 95% confidence limits of that particular peak. You can see that there's two peaks here, and we're selecting for the peak interest. So with GemStone, there is also a pipeline, if you will, and there's a strategy that we use to build a model and to develop our analysis. So of course we add our FCS files, we review and edit the names, the CD measurement names, and the scaling of our histograms. We look and determine our cleanup strategy, which I'm not going to talk about today, but we do have a recommendation in GemStone to use. We are going to define our cell types and populations. And then if we were going to actually develop a full model, we'd refine those cell types and populations and confirm with our Cen-se. I'm going to be talking mostly just about defining the cell types and populations and using a very, very simple example to do that. Before you would add your files to GemStone. Of course, you would do your sample prep and you would optimize it as much as possible. You would perform your acquisition, and some helpful hints for automation in any particular program at all is that you want to name your markers consistently. You want to standardize your acquisition as much as possible, your instruments, and using keywords is very helpful because that can help you later on in your analysis. You can add demographics or whatever. Data pre-processing, you want to do any unmixing or compensation, normalization or debarcoding if you're using Helios or mass cytometry data. And what I'm going to do now is I'm going to build a model from scratch. It's going to be a very, very simple example. I'm going to show you how the program works and how it looks. I'm going to just do a brief introduction. I'm going to create what we call a project, add some sample files. We have a measurement wizard. All of the modeling is wizard driven now. I'm going to show you how to set transforms and edits if you need to. I'm going to use our cell type wizard, which is really the heart of building the model. And that's going to involve a couple different steps. The first one would be our selection, which uses the iconic cell type lineage markers that are present in your panel. The second would be staging, which creates that cell subsets and the progressions that you might be interested in. You can think of T cells with naive and central memory, effector memory, or effector or terminal effector stages. And then we can add any number of functional or other markers such as activation markers, cytokines, and unknowns. And then I'm going to show you the results. So hopefully, all right. You should be able to see GemStone now, is that?
No, not yet, Beth.
Okay, all right. All right, I'm going to have to go back to, sorry.
It's all good. As you're going to share that, I'll let you know when it comes up. And just a reminder to everyone, everyone's been doing this, but please utilize the Q&A if you have any questions for any of our presenters that we can address at the end.
Okay.
Perfect. You're all set.
Great, okay. When we open GemStone, we see a nice blank slate where we can just do whatever we want. What we're going to do today is build a very simple model. First thing I'm going to do is add some data files. So I'm going to click my Add button, which brings up a navigation window. This is sort of programmed right into GemStone, so it will bring you here. You can either add your data files beforehand to your project, or we can navigate away from this window to find them. I'm going to just open up my exported folder, and in here I have 5 different folders that I have previously cleaned using GemStone. I'm going to multiple select those. I'm going to open, and they'll open right into my batch file right here on the left. And the first thing I'm going to do is I'm going to just create, if I wanted to create a new project, I would click this new button and I'd get a window that says you can create a project based on none, add a name to it. I've already done that for us, but so I've added my data files. The next thing I'm going to do is click this develop button. The reason that you would do this is if we were just going to run GemStone in a fully automated mode, the only thing I would do right now is if I already had my template built, I would double click this first file and I'd click auto and it would run through any number of batch files automatically. Right now, we're just going to build a very simple model. So here I have clicked that develop tab. It opens up a different view, which opens up the develop tab, which gives you all of the tools that you would need in order to build a model. I'm going to click on my first file and I'm just going to read the file. And we know that the file is read into the program because here on the lower right, we see the name of the file and we see the number of events and etc. First thing I'm going to do is click on my measurement wizard. It shows me all of the measurements that are in my data file. For now, if I were going to build a full model, I would want to use all of them. I'm just going to say none for now. And I'm only going to choose CD3, CD4, and CD8 because I want to build a CD4 T cell model. I'm going to click next, and it brings up my next window where I can set my transformations. I can do any kind of scaling adjustment that I need. I have choices. We generally use vlog, but you have other choices as well that you can make. When I get everything set that I want to have adjusted, I'm going to go to my next measurement, which is CD4. Again, I can make any adjustments if I need to. I'm going to go to my next measurement, which is CD8. And then I'll go to my next page. I have a summary page of all the measurements that I have edited. I can add this to my Cen-se. I can launch a cell type wizard if I want to continue on. I can update my preferences. Right here, I'm just going to say finish. And I do, yes, want to save my template document. So we try to make this as easy and step-by-step as possible to do the modeling. Next thing I want to do is go to my cell type wizard. I clicked the icon and I get my welcome page. I can create a new cell type. I can also, if I had a full model developed, I would use this page to edit that model if I needed to add markers or whatnot. I'm going to click next. I'm going to type in CD4T, so I want my T cells. This is a competitive, this is probability state modeling. It works on a competitive basis where events are actually assigned, their highest probability would be assigned to this CD4 T cell. I'm going to click next, and I'm going to choose CD3, CD4, and CD8. So these are my selection markers that I'm going to use just for this very simple example. I'm going to create my CD4 T cells, which are CD3 positive, CD4 positive, and CD8 negative. I click next. These are my staging markers. For T cells, we know that CD27 and CCR7 are often used to create those stages or to do the phenotyping for different stages. So I'll use those two. They're well documented and well known. And then for my functional marker, I'm just going to choose one, and I'm going to choose PD1. I'm going to click next. It brings up the actual fitting component of the cell type wizard. So CD3 would be positive for CD4 T cells. I have two peaks right here to choose from. I have the negative CD3 peak. I have the positive CD3 peak. I have my confidence limits. There's my CDPS set here. I see that it's selected. It's on the peak that I'm interested in. And then I'm going to just hit preview. Hitting preview is classifying that particular measurement in this cell type. Now all of the events have gone from that acquisition order to a random order, and I've selected for my CD3 positive events. You can see it's a little bit fuzzy on the edges. There's no hard edges. It's quite different from gating. We don't make any sort of subjective decisions. Going to my next profile, and which is CD4. I want my positive peak, which in GemStone talk we call our brightest peak. We have a positive peak here. We have our CD4 negative peak here. I'm going to just make that a little bit wider because I want my dims as well. And I'm going to click preview to classify. So right now I've selected my CD4 positive, CD3 positive events. Our cell type events at this point are about 64,000 events out of the total file. And I'm going to go to the next profile, which is my CD8. So I'm going to change things a little bit here. I'm going to use my dimmest peak because I want to eliminate these dimmed positive CD8 events from my CD4 positive cell type. Just to clean it up a little bit, I'm going to use something called a low pass. And this changes the CDPs just a little bit so that it will grab everything that's from the top of this particular CDP below it. So if there are any large negatives from compensation or unmixing, we're going to be able to select those as well. So we call this a negative selection marker. And I'm going to click preview. We've eliminated those events. And then going to the next. So our next profile is CD27. We know from experience that we have that CD27 downregulates as T cells become antigen experienced. And we are going to call this a step down, because it downregulates when T cells become antigen experienced. So I'm going to just take those off. I'm going to make my CDPs just a little bit wider so I capture all of those transitional events. And I'm going to click preview. So what's happened now is the program has actually rearranged the events so that the CD27 positive events are on the left. We have a step down and the CD27 negative events are to the right. So these CDPs are not only flexible sort of vertically, but also horizontally as well. And we call this a state. You can see that there's a little bit of fuzzy edges. We're accounting for all those transitional events. I'm going to go to my next profile, which is CCR7. So the program has, because it's rearranged the events, it's starting to add some structure to what we're seeing in the data. And this is automatically become a step down. Once again, I'm just going to check this off, make these just a little bit wider, that a little bit wider, and click on preview. So the program has now identified the CCR7 positive events, and along with those, because the CCR7 and the CD27 are correlated on these events, what we're showing you here are the CCR7 positive, CD27 positive events, CCR7 negative events. And the difference, if you remember where the CD27 actually downregulated, is where that staging comes from. And we'll see that a little bit better in a minute. We still have our, pretty much the same number of cell type events. I'm going to go to the next profile. So this is what we would call an unclassified marker, because we're looking at all of the events that would be in the cell type for PD1, whether they're positive or negative. I'm going to set this as a constant. I'm going to change this, and I'm just going to click preview. So what the program has done now is it's added sort of a delineated what the negatives are from the positives, so we can use another tool further on to actually enumerate the positive PD1 events within each stage of that T cell type that we're looking at. And I'm going to click summary. So it gives me all the information of that particular cell type. I can do another cell type. I can save my template model, update summary map. So what I'm going to do right now is just click finish. And the program now has actually created a report page automatically. We have the phenotype at the top. It's filled in some statistics. We have a live report where we can change our histograms. The histograms are really there for your comfort so that you know that what you're seeing is familiar to you. If I go to my cell types, I can see that we've got the staging. We can see CR7 coming down here, see CD27 coming down here, and this is what is actually creating that staging. So what I'm going to do now is I'm actually going to open up a completed model. I'm just going to open this, and this is where you would actually find your analyzed file or your model. It just takes a minute to read the file in. It's just kind of thinking about it just for a second.
Perfect. And as that's loading, Beth, just so you know, we have about 5 minutes left.
Yep. Good. Okay. Yep. Thank you.
Of course. Thank you.
I think I'll be good. So GemStone, as I said, accounts for all of the events. We have a map here that shows you, what is unclassified. So about 5 of our events in that total file have been unclassified. We have all of our cell types that are identified. We have a cell type page for each one of our cell types in that particular file. So what I've done is I've created a CD8 cell type, CD4, NKT and MATE, gamma delta T cells, B cells, NK mono, MDCs, PDCs. So all of these individual cell types have their own workspace. I have a full report with our Cen-se. We also have summary pages. We can create tables, QC pages. Each cell type has its report page with statistics, overlay plots, whatever it is that you want included in your analysis. And these are all live and customizable. We have a feature called our SSMD, which is a stain assessment index that you can look at all of your staining, which is what this QC page is showing you. And we have many other different graphics and features that you could be using. If I go to my project page, just want to show you where everything goes after you do a complete analysis. So you have a project library. This is the name of my project. And in each of these folders, there is a collection of files that make up the whole project. If I go to my fitted models, this is where all of my analyzed files are. If I go to my graphics, each part of my graphics that I've saved will be here. I can have different comparisons between data files. These are our 5 data files where we can look and see what the expression of PD1 is. I can look at my different Cen-ses. Again, here is that what we might call an abnormal sample. I can look at my different Cen-ses between those different data files. And then just coming back to the report just for a second, I want to show you that Cen-se is actually interactive. You can come here, you can look at different intensities. So this is my intensity of CD95. You can save out these different intensity heat maps. I can scroll through and look at all of the different measurements. And I can also come back and I can draw a region around a cluster that might not be labeled. So the program actually labels all of your cell types. This is CD4 right here. We can see the naive, central memory, effector memory, and this terminal effector stage. If I want to go ahead and analyze and animate that region, I can come back to my other events where I can then just scroll through and look at what might be the phenotype of that unlabeled cluster. So I've very quickly showed you how to build a model, what a full analysis looks like. There are some features that I don't have time to talk to you about today, but I appreciate your attention and I appreciate the opportunity to give you this talk. If you have any questions, you can always email me. So thank you very much.
Wonderful. It was a really brilliant talk, Beth. Thank you so much. And we do have time for, I think, one question because we have about 1 minute left. And Art Roberts had asked, he said you did several manual adjustments during the analysis. Why was this necessary and how do you know what to change?
The reason, there's a couple different reasons that I did that. Generally with our selection markers, we don't change anything. When we come to something like a staging, the reason that I've done this is because I want to account for those transitional events. If you look at CD27, there's some fuzz sort of in between the positive and negative, and I want to be sure that I capture those as well as for CCR7. The other thing with the unknown markers, we want to be sure that we're not capturing any dim events. We want really to just capture the negative events. So sometimes with those dim markers, we need to be sure that we constrain those CDPs just to make sure we're not getting something we don't want.
Perfect. Thank you so much, Beth.